Okay, so what we're going to do is, we now have a bunch of different ways, so let's review them really quick to prove that triangles are congruent. So we'll go around the room, start with Joe. What do I have to prove? How do I prove? I think I have 5 ways, right?
Is this proving a certain one or just in general? Right now we're
2 congruent triangles. I have 5 different ways to prove that triangles are
We
congruent.
have the ASA postulate.
All right, hang on a minute. So, ASA postulate. What does that say, Joe?
Angle side angle postulate, where it means when 2 angles and an included side are
2 angles and an included side.
common.
So 2 angles and an included side. Notice how the initials go. 2 angles, and notice how the side is included even in the initials. So angle, side, angle. Okay? Good. Annie, the second, another one?
You can do SAS,
SAS postulate.
which is
2
two sides and an included angle.
sides and included angle. And notice, I have 2 sides in my initials and an included angle in between them. Okay, if I have 2 sides and an included angle, those triangles are congruent. How about you, Sal?
Do you want to do the A ones first?
Do anyone want to do?
We'll do the ASS. No, I mean AAS.
What?
I have a hard time with that.
Go ahead. This is being recorded now. Go ahead.
The angle, side, and not included side.
Angle, side, and what is this?
A triangle.
What is it? Is
2
it a
angles.
postulate or a theorem?
That's postulate.
No, it's not.
Is it theorem?
Yes, you can prove this to be true.
Oh, my bad. I'm sorry.
The AAS theorem. Okay. All right. And what does that say, Sal?
It says the 2 angles are not included side.
2 angles, and then either of these sides, a not included side, okay, are congruent. Notice here, my side is not included. It's not between my A's. It's not between my angles, okay? It's a not included side. This is different from the ASA postulate. And so on the test, some of you got confused with that, okay? So you have to know whether your side is included or not included, okay? All right, Molly, there are 2 left.
The SSS postulate.
Okay, I think this is probably the simplest, right? SSS postulate. If you have 3 congruent sides, okay, then you have congruent triangles. And I have 1 left. Jordan.
The HL theorem.
The HL theorem.
It says if the hypotenuse and leg.
HL theorem. To have the HL theorem, what kind of triangle do I have to have? A right triangle. You gotta have a right angle. Okay? And if I have a right...
Can you scroll out? Can you just kind of, because, like, I need to finish writing them down.
Yeah, I'm
You're the
writing.
right
I'm
one
taking
now?
notes and this and kind of like flash through.
Okay.
So I just need the SAS one.
Mr. Sager, I have a
Just need all
question.
of them.
Could I
I have
ask
an
a
answer.
question about the test later? Can I ask you a question
You
about
can
the
ask
test?
me right now unless you want to do it privately.
No, I don't care. Number 10. Why was it? No.
Oh, I don't have the test in front of me, but if you want to give it to me. Oh yeah, if you ask me after, I can go through it. I
Yeah.
went through it with Jordan yesterday. Yeah, I didn't write the answers on there. Okay, are we good?
Yes, sir.
Oh, wait.
I'm amazing.
We're still there on the SSS postulate. It's all right.
I think
And yeah, I would suggest some of you, I know you're putting in your notebooks, some of you have the index cards. That's what I really like. And when I studied these things, that's what I did. I put these things on index cards, and then I used them as flashcards so that I could, look at that. And then on the back, I would have a picture and a definition. And that, some of you, that may help, okay, rather than the notes. But
Works really good. So
okay,
find the picture that goes in the thing.
all right. The HL theorem, Jordan, then says that if I have a right triangle, what do I have to have congruent in order to prove that it's right?
Legs and the hypotenuse.
Say that again.
The 2 legs and the hypotenuse.
Not quite.
1 leg.
1 leg and a hypotenuse. That's why you have 1 L here and 1 H. What is the hypotenuse, Jordan?
The one that's like not included in the right triangle. Or not the right angle. Like
A hypotenuse is a side.
yeah.
How do I find it? It's opposite of the right angle.
Yeah.
Okay, the hypotenuse is opposite of the right angle. Yes, it is the longest side. But some right triangles, you may not be able to tell which is longest by looking at it. Because what if I have one that's an inch by 1.001 inches? You know, well, that wouldn't work because it's got to be a square foot. But you get my point. You can have them so that you can't look always at the picture and say, you know, which one looks longest, tell by the picture. So always look for your right angle. It's opposite of your right angle. So if I have a hypotenuse, and it could be either of the legs, but I only need one of them. If I have the hypotenuse of one of my legs congruent, then I have congruent triangles. All right, so now what we're going to get into today is using everything we've learned. And you can't always prove, as you saw by the test yesterday, you can't always prove that triangles are congruent directly. So sometimes you don't have enough information to prove that triangles are congruent. So sometimes you have to use other triangles. So let me get my pen out and let's see what we'll do here. So let's start with this. So this looks kind of like a kite, right? A little bit.
Oh, is this our new lesson?
Yeah.
Oh, we didn't look right. Oh, okay.
I'm just drawing a little diagram here. So I've got 4 triangles there, right? Well, actually, how many triangles do I have here?
Four.
One,
Oh, well, 5.
two, three,
Wait, no, 4.
5, 6, 7, 8.
8. Yeah, I found 8. Good.
Where did you get the 8?
Well, I got 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I've got 8. And let's get some given information, right? X is the midpoint of BD. AC is perpendicular to BD. And they want us to prove angle ABC is congruent to angle ADC. Okay? All right. So, and everyone's on the worksheet here, page 55 at the bottom. This is the diagram we have. So X is the midpoint of BD, and AC is perpendicular to BD. So let's mark up our drawing a little bit. So what do we know if we have X is the midpoint of BD, AC is perpendicular to BD? That's what do we have that?
That's a given.
That's given. And how do we want to mark our triangles for that?
So, I don't know, how do you define like a midpoint on a drawing? I just,
Well, you
Well,
use
so
it means
I
that
just put a
BX
parallel
is going to
lines.
be parallel is going to be congruent. It means BX is going to be congruent. Line segment BX is going to be congruent to line segment XD.
Good. And that's the next statement, right?
Yep.
Definition of a midpoint. All right.
But also,
And then we have some information about some perpendicular lines, AC and BD. So what does that tell us?
it tells you all 4 lines are 90-degree angles.
Well, all 4 lines are right angles?
Or all
a line
4
can't really be a right angle.
Oh, okay.
All 4 angles
yeah.
are right angles.
Yeah, my bad. I meant the 4 lines.
Okay. And so we have for number 3 a reason if 2 lines are perpendicular, then they form congruent adjacent angles. Okay? So what are the 2 angles here for number 3?
BAX and
BAX?
no, never mind. That's a triangle. Never mind.
Well, that's an angle as well.
I guess.
But that's
Angle
not the angle.
BXA.
BXA. BXA and what?
BXC.
BXC are right angles. Good. And
Wait, is that an answer?
sure. You could also put in AXD or CXD. Well, all 4 of those are right. That's why I put them on my. I put all 4 of those are right angles, right? Then I have the reflexive property. So what do I have here? So
AC is a line
so
segment.
I have these are congruent. I have these are congruent. What do I want? Let's start with what I want to prove because this is what I want to look at here. Prove ABC. So that's this angle here, and ADC, ABC, the big angle up there, I'm
Yeah.
sorry. The big angle and the smaller angle. So in order to prove those are congruent, what do you think I'm gonna have to prove? Which triangles?
The two big ones.
ABC and ADC, right? Okay, because then I would, through CPTC, we have the congruent angles, good. So in order to prove these triangles are congruent, I'm not going to be able to do that directly. So I'm going to have to do some other things. So what do I have that would be similar on both of those triangles that would be reflexive, Sal?
Line BD is reflected to BD,
No,
or AC to AC.
Well, which? You gave me two different lines. Which one do you want?
BD.
I want to prove that this, hang on, let me do it like this, because that might help you. I want to prove this triangle here
Okay.
is congruent to the one below it, right?
Right.
So BD isn't really a part of those triangles. So
No.
what would be a part? See how they
AC,
both
but
have
the-
AC.
But AC is not congruent. Oh.
AC
oh,
is congruent to AC through the reflexive property,
Yes,
right?
I was thinking the point X was going to be throw it off. My bad.
Sorry.
You saw the X's and center side. My bad.
So those are the two triangles there that I want to show are congruent, right? All right. So I have that through reflexive property.
So
And-
it's AC is congruent to AC.
I have,
Yeah, that's number 4. Yeah.
But that's also on number 7 too.
right, which is probably where I want to put that. So I have to prove that. I want to put that under number 7.
But it's
The
There's
order,
reflexive property twice.
it's going to be twice, yes. Well, anytime you see AC is congruent to AC, that's going to be the reflexive property. So that's going to be the reason for number 7.
Okay, who is
and
it?
number 4. So what do you want for number 4?
Number 4 is also the reflexive property, but so we have AC is congruent to AC. What else do we have congruent to each other?
Oh,
AX, I guess. AX. Well, I mean,
If CX is congruent to CX,
Say that again?
if CX is congruent to CX,
CX is congruent to CX.
or AX, or you could
Okay.
do, but I mean, it doesn't really matter. You could just do AC for both of them. It doesn't. It's not say. It's not nothing that says.
All right, notice what you have up in number 5. Look at number 5 here. You have triangle ABX, which is this small
Okay.
triangle here, right?
AX.
Is congruent to triangle ADX. So you have these two triangles here, and I'm gonna call this triangle 1 and triangle 2. So you understand what I'm talking about here? So that's triangle 1. Those are the little ones. Triangle 1 and triangle 2. So in order to prove these are congruent, what do I have? I have already got a right angle, right?
Mm-hmm.
And I have a leg, right?
Yep.
Okay. What else? So what else do I want to do here?
How
So
about
if
this?
you.
Well, actually,
Oh, that
Well,
one.
you
There's
have
no
a
way
side-
to- there's
side
no way to-
and side. If
Side and
you
side.
put AX,
all right. So AX is congruent to AX.
yes,
And then you have.
and that's number 4 now.
That was number 4. AX is congruent to AX.
And then you have the SAS postulate for number 5 because you have
Yes. Yes. You
an
do.
included angle.
Yes. So number 5, your reason is SAS. Is anyone confused, or has everybody got that?
Well, I made the connection earlier, but I thought it was wrong, and I was like, that must be wrong. And
No,
it's like,
you're okay. All right. So now,
Line, you never made a connection.
so then what I try to do is, and don't be afraid to mark up your diagrams, because it'll help you. So now I have these two triangles congruent, right?
Mm-hmm.
So what else is congruent, Jordan? Just give me some things that are congruent. CX.
Yeah.
Well, no, these two triangles here are congruent. All their corresponding parts are congruent, right?
Yep.
So what are their corresponding parts?
Line 80,
And AB. What else?
angle D,
Well, angle D is ambiguous. ADX
yeah, that's what, yeah.
is congruent.
Yeah.
And then those are congruent, right? So once you have that, then you have all those things. Now, I'm not saying you're going to need all those things, but I mark up my diagram. You may not need all those things, but those are all true. You could say all of those through CPTC.
CPCTC.
CPCTC. All right. So now I have AB is congruent to AD, and what was my reason there? and BAC is congruent to DAX. DAC, sorry. You could call it X, but it's DAC as well. And what's the reason there, Jordan? Well, we just marked up. We just marked up our triangles. What was the reason we used? You have two congruent triangles. All their parts are all their corresponding parts are congruent. What's the theorem that says that? Or who can help them? Go ahead. CPCTC.
Oh.
Corresponding parts of congruent triangles are congruent. Okay? So once you have those two, so you have that. AC we already said for number 7. So now what do I have? Do I have enough on the big triangles yet?
No. Well,
What do I have?
You have a side angle side.
I have a side here is congruent to a side here.
Right.
We had the whole thing was congruent to the whole thing. And then we have these here, these angles here.
Yep.
So you can say now triangle ABC is congruent to ADC, right? And what's the reason, Sal?
Side angle side.
Side angle side, yes.
And then so number 9 is CPC.
Number 9, yes. The ABC, this whole angle is congruent to this whole angle because of CPCTC. Once you have congruent triangles.
What if for number 2, if we write a proof on your search paper for it, because there's no room.
I'm sorry, what?
For number 2, if we're going to do that, can we write a proof on our separate sheet of paper?
Sure, you're not going to turn these in. These are just for your notes.
Yeah.
You can write them wherever you want. I'm going to use the same diagram though if I give me a second here. Okay. Okay. And
Can you circle it and tap?
what?
Can you draw a circle around it and erases it? Like circle and tap?
Maybe, I don't know. I haven't done enough with the eraser. I usually just go to a new page, but I want to keep the same diagram for the next one. It's the same diagram, so I don't have to redraw it. Although by the time I erase, it's probably easier to redraw. So, all right. Number 2 says that X is the midpoint of BD still, okay? And it says that BC is congruent to
BD. DC.
DC. Do 2 of those because we have 1 over there. Okay? And it wants to prove that angle back is congruent to angle DAC. Right? Huh? Okay. So, let's see. BAC is right here, and DAC is right here. All right. So how are we going to start this, Joe?
Would.
Let's start with Joe.
Sorry, I'm just writing. I'm
Take
writing
your
down
time.
this proof on a piece of paper, so I'll have it as notes for tests.
Okay.
Well, here we are. So, we have any given? Is that our given information right there?
It was
No.
X is the midpoint of BD. X is the midpoint of BD.
So it's same given information. Everything's the same.
So, no.
Well, we have to prove something different, but
And they gave us no. They gave us this time. They gave us those.
okay.
Okay.
So first,
So-
we can start off with first step is give.
Right.
So we wrote that down,
Right.
and then
And then we can say these two things were congruent
yeah,
because of what?
because of the definition of a midpoint.
Correct.
And do you want me to continue?
Yeah.
Okay. Afterwards, down. Okay. You ready to write that down?
Tell me about it.
Okay. So that's the definition of midpoint.
Right. So now I got those. Now what?
So now you have two sides. You have two sides.
You want to go through your ways to prove triangles are congruent. There's 5 ways, and say, which one can I use?
Well, if you do a reflexive property
For what?
first I'm trying to figure out what we want to prove congruent. If we prove BXC and DXC,
Yeah.
are those, that's it, name it right, because I don't know how to name it.
BXC is this angle right here.
BXC is the one on top. Those, if we,
Which angle are you talking about? This angle up here, or this angle down here?
well, okay, what I'm saying is, if we say that XC, line segment XC is congruent to itself,
Right, that's what you
the
want to do.
reflexive property.
That's what you
say
want to
that.
do. That's what you want to do next.
Yeah. say that.
XC is congruent to XC. Then what?
Then we have these two triangles congruent to each other.
What are the
because
triangles?
of the SSS postulate.
What are the triangles?
That's what I'm bad at naming.
You just pick-
DXC and BXC?
DXC. Right, the best way to do this is what I told you guys is, especially when you have things that are reflexive, see how XC is always congruent to XC, and they have to correspond. So use those, and then what's the other one you have? B? Just throw it in, you'll name it right every
How do
time.
you know because that's how it
What's that?
How do you know?
Yes, that's right.
He has 3 sides, SSS postulate, that's what he said. Okay, so now we have 2 congruent triangles.
Okay, and now we can, from this, we can name that all the angles are congruent. So we can
Well-
say angle B is congruent to angle B.
No, you can't say angle B, because angle B could be
Oh,
this
angle
angle, this
BX.
angle, or the big angle.
Angle BXC
BXC is down here. BXC.
or BCX. That, or
BCX is over here. Is that the one you want?
XBC.
XBC.
XBC, you can say this angle is
Yeah,
congruent
that-
to this angle
I meant that one.
because of CPCTC. Okay,
And then,
Wait, well, what would be the point of saying those two are, angles are congruent if you're trying to prove DXC?
remember, he's just saying that you could say those.
Okay.
And I suggested that you can say more than that. What else could you say,
yeah,
Joe?
you can also say that those, the two sides of C, you know, the two.
Gotta name it, gotta practice saying them. So, all you want is the vertex in the middle. So,
XCB.
XCB. XCB. So this angle here,
It's congruent to XCD.
XCD,
So
through CPCTC.
Okay.
And what else?
And also you could name that nothing perpendicular. You can name that DXC.
DXC.
So that angle is congruent to BXC.
DX. Right, you could do
And
that.
then vertical.
Okay.
And then because of vertical angles, we can
Whoa,
say.
whoa, slow down, slow
Okay.
down, slow down. Say that again now?
And then.
What do you say about vertical angles?
Because that wouldn't DXC be congruent to
DXC is congruent to
AXB.
AXB
Would that?
because of vertical angles are
Yes,
congruent.
okay,
And also AX, they're also congruent to AXD, right?
yes.
And
Does everybody see that?
then my grand finale solving the
The
problem.
grand finale, well, let's see. So now what do I have? I'm still trying to prove that BAC, I'm trying to prove this angle is congruent to this angle.
So you have one side. Well, you have a side, and you have.
Jordan, what do you think we do next? Guys, don't do that. Don't give each other the answers. It's a lot easier if you work them out. It's a lot harder, but you'll learn them better.
I don't know.
Go ahead, Sal.
AX is congruent to AX.
AX is congruent to AX. Now what do I have, Annie?
can you do side angle side?
You could do side angle side to say what triangles are congruent though.
Triangle BAX.
BAX.
Triangle
Triangle BAX is congruent to triangle BAX.
Wait,
I kind of had a heart attack because I thought the period was over, but then I realized it was a chapter
What?
day.
for the reason, I don't understand, how you could make them congruent.
Which ones?
How the vertical angles would contribute into the ASA postulate.
You know that these angles are congruent to each other. Because all 4 of these angles are congruent to each other. All 4 of those angles are the same measure, right? All right, so once I have those triangles congruent, what's the next step, Michael?
Proving that two angles are congruent through CPCTC.
And what are the angles?
BAC angle. Oh wait, we didn't prove the whole triangle was congruent.
Yes, we did. That's what she just did.
Oh,
Triangle
I
backs is
said-
congruent to triangle backs.
So yeah, we do prove that angle BAC is congruent to
DAC through CPCTC. All right. Any questions on that? All right, let's flip to the back side. All right, so what do I got here? I've got and then I got A, B, C, X, Y, D, and I have angles 1 and angle 2. Okay. And then I'm given DB is perpendicular to AC, AB is congruent to CB, angle 1 is congruent to angle 2. Okay, so AB is congruent to CB, and BD,
There's a line.
oh, there is a line that I didn't put in, that's why. BD is perpendicular to AC, and 1 and 2 are congruent, so we know those are congruent. All right, and then they want us to prove and they want you to prove that XB is congruent to YB. All right, Jordan. Let's not worry about the sheet and the look at hunting for the steps. Let's just prove it. So how would we prove this? What's the first thing I'm going to say?
DB is perpendicular to the line DB, perpendicular to line AC.
D.
You already did
Right,
that.
all right, the given. We'd write all the given down first. Yes, I understand. After we do all the given, what's the next thing we're going to do?
Line BD is congruent to line AB.
Okay. BD is congruent to BB. And what's the reason?
Look in the mirror.
Reflexive property.
Oh yeah.
It's always reflexive when you, yeah.
Could we do angle AB or XBA and
X-
and
XBA,
YBC are vertical angles and get the A?
they're not vertical
Well,
angles.
can you because DB is perpendicular to AC, can you say that if two lines are perpendicular, then they form congruent adjacent angles with, or did we already do that with?
Yes.
Yeah, we can say that.
This is definition of a right,
Yeah. So,
definition of perpendicular lines.
but I was
So-
saying, can we do that? Can we say that XAB is congruent
X?
to XAB is congruent to Y?
XAB is this angle here. Is that what you're talking about?
Yeah.
It's congruent to what?
It's congruent to YCB. Would we be able to do that?
What would be the
Because,
reason?
If two lines are perpendicular, they form congruent adjacent angles.
But these aren't congruent adjacent angles. Over here.
I don't know.
That's why you.
That's why I asked.
No, those aren't a congruent. These are the congruent adjacent angles here.
Oh, okay.
ABD is congruent to angle D, or sorry, CBD for that reason.
So I
Okay.
got the right idea wrong.
Then you can do the AAS postulate right there.
Where? What triangles are you going to say are congruent?
No, you got a big angle. My bad.
Alright.
That's not a triangle.
Well, if we can show that dx is congruent to dy line segment somehow, then we could have a triangle up there. But how do we do that?
Okay, well, we're not there, so.
Okay.
Who has an idea of where to go next?
After that, I would do angle ABD is
ABD is,
equal to CBD because
that's what I did, I already did
two
that.
lines of yeah.
Right, I did that.
What if you did AX, wait, no, what's the thing, if two lines are
Guys,
supplementary?
look what we have. What do we have already? We have
A
a side, another side, and an included angle, right?
Yeah,
So
Yeah,
what's
so ABD is congruent
Yes,
to,
it is.
the triangle ABD
ABD?
is congruent to triangle CBD. Is that correct?
Yeah, because of what?
Because of the side angle side postulate.
Good. All right.
I thought I was thinking of that, but I guess I didn't. I don't
So
know.
now we have two congruent triangles. So what does that tell me?
Congruent parts of congruent triangles are congruent, so we can say that D.
It's
Corresponding.
CPCTC, yeah, corresponding
So
part.
because of CPTC, we can say that.
Well, let's before we start doing all that, what are we trying to prove? XB is congruent to YB. So in order to prove these are congruent, we probably want to prove these two triangles are congruent, right? Because
Yeah,
once
so-
we prove these two are congruent, then through CPCTC we'll prove those. So how can we use these triangles to prove that these ones are congruent?
Would we be able to say that because of CPCTC, line segment DX is congruent to line segment DY because they're both part of congruent triangles?
We haven't proved that. We haven't proved that these triangles are congruent.
What would prove?
You proved AD, not DX. DA is congruent to DC, but you haven't proved that DX is congruent to DY.
like you haven't proved that the other ones exist inside of it.
We
Could
can
you do
prove
the
big
supplements,
triangle,
like, where you add the two angles to, like, you were trying to tell me this on the thing.
All
where
right,
you add
this
the
one
angles.
here. So Sal's saying that these angles are congruent because why?
They're supplementary, it's where you add, they're both.
Supplements of congruent angles are congruent,
Yeah, I can't say.
right?
What?
This was on the test yesterday,
Yeah, I just couldn't get it out.
right? Notice these, we know these are congruent, so then angle DXB and angle DYB have to be congruent because supplements of congruent angles are congruent, right? Yes? No? Does everybody see that?
Yeah.
Okay.
Well, you could prove the two big triangles. Like if you combine the smaller triangle and bigger triangle on each side together, you can put
That's
them
not one of the given reasons. That's not one of the reasons.
because
I didn't say we were doing one of those given reasons. I said let's prove it.
Why?
Some of these have more than one ways to do it. I told you not to hunt through the page, but I don't have the key with me, so I'm just gonna prove it to you. So,
Could you say that one more time? I wanna write this down now.
which one? This
The
last one?
supplementary,
Supplements of congruent angles are congruent. Okay? So what do I have now on these two triangles that I'm trying to prove congruent? I have a side and an angle. So I either have to prove that this side and this side are congruent, or I have to prove that one of these other angles are congruent.
oh, with the two angles, no, you can't really prove that.
Is that
So we have
what
an angle, and a side.
the one who came up with the two lines that are perpendicular there, they form congruent adjacent angles? That you got that off the sheet?
No.
You knew that? Okay.
Yeah. No. I was just looking at my prior notes, and I thought that if
Okay. Go ahead. I'm sorry.
Would
Eric Mom.
would the angle AX be
AXB,
AXD, ABD, sorry.
AB,
So
D.
X.
Yes, I see it.
D, XBD.
Yes.
Be congruent to DBX or Y.
DB,
Y.
DB, what?
Is that a Y? I can't tell.
How would you, for what reason though?
Because both sides are 90-degree angles, and then if those two triangles are congruent, then
What two triangles?
didn't we prove that triangle AXB is congruent?
No.
We didn't prove
No, we
any
proved this big triangle is congruent to this big triangle.
Never mind.
Okay.
well,
So-
if we can get one more side on the top triangle, but we do that. Let's see.
could we
Okay.
do
Go ahead.
X, D, Y
X,
is,
XDY is this big angle up at the top?
yeah, wait, what are we trying to, like, what do you guys, Because if we did that one, it'd be an angle bisector, or
Would
it'd
it be congruent to what? This angle's congruent to what?
no, you could say itself because of an angle or no, no, never mind. I forgot how to say it.
This is congruent, angle x dy is congruent to itself, but I don't see how that would help you. You could say anything that's congruent to
Yeah,
itself.
I don't know what we're trying to, what we're not on.
You're trying to prove that this little thing here is congruent to here.
Okay.
So you can do that one of two ways, by proving these two triangles are congruent or these two triangles are congruent. And then either way, because they're both parts CPCTC, will prove that's true. Because you either have to prove these two big triangles here, namely this one, are congruent, or the little ones are congruent, one or the other. Okay?
Okay.
So for this one, you have two congruent angles and two congruent sides. Or for this one, you have two congruent side and congruent angle. So which one do we want to go after?
I don't know, because I don't know how to do either of those.
Okay.
Wait. What if you did the A? Oh no, it's included. Never mind. Now it won't work. I was gonna say, what if you tried to do? What if you tried to say angle ADC is congruent to itself, and we did that, and we tried saying that the A by the AA as
Well,
positive.
ADC is this big angle up there.
Yeah, I know, but I was thinking if by saying that we could say that the top triangle now has two angles that are congruent in the sides, but that won't work because it's
Okay.
What happens if you
Speculation.
proved this triangle, like this piece right here?
You gotta just name it.
I don't remember.
XB.
Right, yeah.
X
Well, if you cut it in half
XB.
by bisector, then wouldn't that then prove the triangle with an AAS postulate?
Well, yeah, but how do you know that that's a bisector? You can't just look at the picture and say it looks like a
I
bisector.
said it was a bisector, I thought.
That wasn't anywhere in the. That wasn't anywhere in the given.
Oh, okay. Never mind.
No, if you had that, you're right. But yeah, you can't just look at the picture and say that.
I
Now look at
thought
the
it
picture. I know
said
that is a
bisector.
bisector, but I can't say that.
Okay, my bad. I'm sorry.
Okay. What else do we have?
no idea.
XB. All right. So if you look on your sheets, you definitely these are the triangles that you're going to want to prove congruent here, the small ones, and because it gives you that already on your sheet. Okay. And so you already have an angle here, and you have a side. So you either have to prove.
Oh, it's time to go.
Lunch
Bells aren't
after.
ringing today.
Is it after lunchtime?
Yeah.
Oh,
Oh,
you're
guys.
after lunch? 3 minutes in for lunch? Are you kidding?
I want to see how to solve it.
We will. Well, you're welcome to stay if you want.
Okay. Wait.
Your lunch actually ended 3 minutes ago.
Our lunch ended 3 minutes ago?
Well, it started 3 minutes ago. Sorry.
Oh, I should have seen that.
I'll stay and watch.
Okay.
Stay and watch this one.
We want to. You're going to prove that these are congruent. So 1 and 2 are new is congruent. A, B, D.
Steven, just have a good day. Have a good day.
See you. It's through AAS. So angle side, so it's going to be one of these angles. And now angle A is congruent to angle C. Oh, we had these big triangles congruent, so that means the course parts those are
Oh, wow.
There you
Wow.
go.
That was fun. Very fun.
Exciting, wasn't it?
Yeah. Kind of upsetting. That's like what happens to me on my math test. Is I forget that I made something else something.
Well, that's why I said before, didn't I? Once you have the triangles congruent, make everything, prove everything.
Yeah.
As long as you use CPC, you're not wrong.